Hello, welcome in the fourth episode of STM32 Zero series. In this series, I am going to discuss the CubeIDE install and install. So, what is CubeIDE? So, first of all, let us understand the analogy. So, if you are consider yourself as a chef and if you want to, make some recipe. So, recipe means it's a C code. Then CubeIDE will be a kitchen, right? Where each and every tool will be available. You can use those tools and write your recipe or write your C code. Okay, and finally you can upload that C code into the STM board. So STM board will be your dish, right? So using CubeIDE you can cook everything. So whatever code you want to write, you can write using this CubeIDE. In CubeIDE, one tool, write code, build, flash, debug, all in one place. So you can have this explorer where you can see all your files. You can have editor where you can write or change your code. You can have build. So here you can compile the code. Now in that programming language episode, I already discussed about different stages of programming language, right? And how compiler convert your high level into machine and all. So build option will exactly do the same thing. It will compile the C code and generate machine code. Then we have debug. So using this option, you can find the error, you can run code step by step. And finally, you have flash. So using flash, you can directly upload your code on actual hardware and it will run with full speed continuously, right? These all are options you can use in CubeIDE. So now how to install? So installation step is very easy. So I'm not going to discuss this here, but you have to simply download it from Google, right? First step is on Google, search for this, open ST's official website, search for this STM32 CubeIDE, right? Then you have to select your operating system. Okay, it's Windows, Mac or Linux. Then you have to create free account. You have to give your email and password. Once it will be ready, you will get the download link in your email. So you can simply download it, run installer, and it will install required thing in your PC. And once it's done, you can simply open it, right? And then you can use the IDE. You can access its workspace, right? Means you have to select the workspace and then it will start open all the required things, and you can select menu, you can open existing project, you can create new project, everything, right? So this is how you can install this. Installation is not that much difficult. So once you have downloaded, you can simply click on next project selection and finish. It's very easy. Then now let us discuss about every panel in the IDE, CubeIDE. So left side you have projects explorer where you can see multiple files are there. In center you have code editor where you can open the file from the explorer and edit over here. So it's like a Microsoft Word for this, but this is for the coding. Okay, so here you can change required thing. Then you have console. So in bottom you can see this is the console. So it will show you the messages while building. So once you click on build, it will try to convert your C into binary, and if any error is there, so it will show all the notification over here. If everything is okay, it will simply display message like build successfully with zero error or zero warning. So here in console you can access all this. Then you have outline view, right side. Here all the functions will be there. Simply like a table, click on any function and you can open that function. You can jump to it, and then problems. So here it will list all error and warnings over here. So this is what the CubeIDE layout diagram. Now Build Debug Flash. So here we have to understand three main buttons, right, which we'll use throughout the course. So three buttons are, first is build, hammer icon. So here you can see, first of all, you have to write your code. Then using build option, it will convert your C code into machine code like a baking cake. So this I already discussed, right? In C, you have the C language programming, and machine language, you have 0, 1. So here compiler will do this thing. First, you have to simply click on build icon. It will convert your C code into binary, right? And if any error is there, so definitely in conversion, it will not miss, it will face some difficulties, right? Because some predefined rules are there. And if you have any instruction error or if any coding error, then it will definitely not able to convert this binary file and it will display error. So you have to first fix those error into editor, then again click on build, and again you will have hexadecimal file. Then you have debug icon. So it's like a bug icon. Now, after build, you can send your code to board, and using debug, you can run line by line slowly. Okay, so yeah, let us say your code is having 10 lines. So here using debug option, you can run it line by line in editor, and at the same time, it will also run on the board. Let us say after 5th line, you have some logic to turn on the LED. So when you click on 4th line, then next 5th, so it will turn on the LED on board as well. So from editor, you can see your compiler is at 5th line and the LED is on now. So this is how you can run your code in slow motion. And this is especially for during development phase where you don't know how your code will work and you want to identify some bugs, some issues. So you can use debug mode. And if you have everything working perfectly, you can use run or flash option. So using flash option, it will build and it will send entire code to the board and it will run at full speed. So here now, once you click on flash, your code will goes into your board and then your board start executing it independently. So you can remove this board from the laptop and provide power supply from anywhere, from charger or for power bank also. Your board start executing that code at full speed, right? So this is, you can say, production environment. And stop, so you can stop the session. Okay. Now in debug mode also you can see the variable. So it's basically for debugging. So how variable changes its value, everything you can check over here. Now debug versus release. So this is very important thing, and in our throughout this series we will use this. So again, as I already discussed, that debug use when finding bugs, and release use once code work fine. So I already explained you the debug portion. Now release means once you sure that your code is perfect, now every flow is proper, right? Everything is working as per the expectation. You can directly click on release. It will generate hexadecimal file. It will upload using Flash on the board, and then your board start executing independently. So release mode you can consider as a final working code, and simple rule: code not working, testing, use debug mode, and if code already working, just use release mode, generate hex file, and upload on the board. Okay, now first project. So first project, how you can open it? Simply click on file, new STM32 project, select your board, give your project name, use pin view, and generate code, and you will have this main.c file ready to use, ready to develop, not use, right? So once configuration part is done, you can directly have this main.c file with some predefined functions, and you can use it. So now this is CubeIDE. So first of all, click on new, then select STM32 project. So it will initialize 32 target selector. Now here you have to select the target. So if you have microprocessor, MPU or MCU, you can write your part number over here. Since we will use board, so I'm just typing my board name, Nucleo 144. Select the target. Now here different ICs are there, different commercial part numbers are there. So select as per your requirement. Now click on next. Paste CubeIDE. This is the project name I'm giving it. And next, then finish. Now next it will open the pin selection option, where you can configure your pin as per your requirement. Okay, and this is again based on your selection. So our target is Nucleo F767ZI. Okay, firmware package is this. You can upgrade the firmware if new firmware is available. So it will load the IOC and it will render the UI. Once it complete, you will have that pin selection option. So now it is creating the project for us, right? Some pre-configured things will be there. Once you complete the pin configuration selection and all clock configuration, you will have sample code ready with you. Here you can see this is the IC. This is LQFP package, 144 pins. Different pins are already configured. So first of all, we have to clear them, right? Because for specific operation, we have to have specific configuration. So now I'm clearing all the pins. Now here you can see it's a raw IC. Now for any microcontroller, required thing is crystal. So you have to select RCC, HSC, crystal ceramic. And once you configure it, you can see 2 pins will show this, right? Oscillator is connected with this. Now let us connect any LED with any pin. So let us say its LED is connected with PB7. Okay, so I'm just clicking over PB7 and configure it as an output, because LED will be external device. And if to turn on LED, we have to write some voltage from the microcontroller. Direction must be in output, right? Signal will goes from processor to LED. So now output. Now this is single pin configure. I just configure single pin. You can do this for multiple pins as per your requirement. And once ready, simply click over here. It will generate the code for you. Okay, and here you can see paste CubeIDE. It is generating different files for us. Right? This is the advantage of HAL. The hardware abstraction layer will be there. Predefined thing will be there. Right? Here you can see this is the project. Click on core. Click on source. This is main.c file. And as you can see, many things are already configured over here. System clock, GPIO. Here you can see PB7, right? As per our selection. And now you can directly edit this main.c file. In main function in the main.c file. And then you can turn on and turn off LED by simply editing this portion, right? So this is how you can generate the code. The predefined functions will be there. Directly edit this main.c file and you can develop your required operation, right? So this is what for this episode. Thanks for watching.